Now, important stuff. This is where you can score for your project. Right? So if you independently read further sections of the textbook, section 9.6, 9.7, or 9.8, and if you apply that material in your project, then you will get a higher score. Right? So the sections about the following thing, about the following three things. So first is basin of attraction. So like here, you see that we have this unstable critical point, and we have this stable critical point. The question is, where does my solution have to start in order to eventually end up here? And where does it have to start to eventually end up here? So basically it is clear that there is some kind of an area here, and there is some kind of another area here. One of them is attracted to the first critical point, and the other to sort of the second critical point, and this is called the basin of attraction. So how to calculate it explicitly is explained in section 9.6, and if you do that, you can get some extra scores for your project. Well, then nonlinear systems sometimes exhibit behavior more complicated than just critical points. So one of them is a closed trajectory, so that other trajectories just approach it or go away from it. So approach it either as t goes to plus infinity or to minus infinity. And this is called a limit cycle, and limit cycles are explained in section 9.7. So again, if you can prove that your model in your project has a limit cycle, if you can prove it rigorously mathematically, then you can get some extra scores. And finally, kind of the hardest one is strange attractor. For a strange attractor, the system has to be to have at least three equations. So this is not possible on the plane, but it is possible in the three-dimensional space. So again, if you can prove that your system has a strange attractor, it's going to be very beautiful, very interesting. So then you'll get some extra scores. I would like to mention a few words about Kolmogorov's predator-prey model, which is different from the Lotka-Volterra model. But just in case, if you this is not in the textbook, but maybe you want to explore it a little bit further, so maybe it'll help with your project too.